So in this video, I will be discussing Codeforces Goodbye 2024 and 2025 is near. So yeah, I will be discussing first four problems of this set. Let's start with problem number B as A seems to be easy so yeah, let's start with B. So the name of problem is Outstanding Impressionist. So in this question, we will be given some ranges for each and every index. For example, L of I and R of I, which means my current value of my array will be between L and R. Okay. Now what they are saying, the value should be unique for each and every index. For example, let me share with the screen. So yeah. So for example, my for my first index, my L and R 1 and 4. For the second index, for example, they are 1 and 1. And the third index, let it be 2 and 3. Okay. So tell me, can my first index be unique? Can contain a unique value? So let me just make a dry run. So yeah, let's suppose I'm choosing a value. So my each and every value in my array will be between L and R, right? So I can choose a value of, for example, 2. Okay, I have chosen a value of 2. So now I'm choosing a value of 1. Okay, over here, because both larger and smaller range are equal, so value would be 1 only. And in this range, suppose I choose 2. So is my this index unique or not? No, this is not unique. Here you can see 2 is there. So yeah, it is not unique. But if I choose 3 over here, so yeah, I can also choose 3. So yeah, if I choose 3 over here, now this value is unique in the particular array, in this whole array. Yes. So yeah, which means there is a way to choose some of the numbers in these ranges such that my first index is unique. So yeah, I'll write 1 over here, which means this can be unique. Similarly for the 1, can my 1 be unique? So yeah, you can see my 1 is also unique here, right? So it one is for this also and one is for this also. Yeah. So you must be thinking, then the answer will be like one for all of the cases because they can be unique in each and every case. But no, this is not the possible case. So I'll tell you another example. Now for example, my range is 1 comma 1, 1 comma 1, and suppose 2 comma 3. Okay, done. So what number I can choose? I can only choose one in this case, one in this case, and suppose I'm choosing 2 over here. So is this unique? No, this is not unique. And I cannot make another configuration also to make this one different because this is matching with this index only. So yeah, for this it is 0. Or similarly, can this be unique? No, this can also not be unique because similar one I have already found. So yeah, 0. But can you tell if this is unique or not? Yeah, this is unique. But how? There is no other 2 in the whole array. So yeah, for this I'll write 1 over here. So yeah, these are the one this is the one condition in which my 0 will come because in this case my small and larger lane are both the equal. And yeah, and totally I'm having two such ranges in which both the smaller and larger range are equal. So yeah, the output for them will be 0. But there's another one more case. I'll tell you what is that case. For example, I have given a condition like 2 comma 4. Okay, I'll change the color. So ranges are 2 comma 4, and I am given another range as 2 comma 2, another as 3 comma 3, and another as 4 comma 4. So tell me, what are the ranges which I will select? So for example, if I select 3 over here, okay, 2 over here, because I can only choose 2, here I can only choose 3, and similarly 4 over here, right? So yeah, is my 3 unique or not? My 3 is not unique. So I'll write 0 over here because there's another more 3 present in the array, right? So for this particular 2, can my answer is unique? Yes, my answer is unique, so I will write 1 over here. But can you see whether this is unique or not? You will tell me, like, you will notice that this 3 is equal to this 3, but you have to consider, but you have to redefine ranges for each and every particular index any times. Okay, let me repeat it again. You can redefine ranges for each and every index any number of time. For example, for this 3, if I want to modify the ranges, I can modify the ranges. So I'll write 4 over here. Now the modified range will be 3. It will be 2 and it will be 2. Now for this particular index, I will modify my first range. Now for example, if I am using 2 over here, right? So this configuration is also possible, right? This configuration is also possible, and in this configuration, my 3 is unique. So I'll write 1 over here. And similarly, in this configuration, 4 is already unique, so I'll write 1 over here. So yeah, but can you tell me, in any of the configuration, can my this first index can be unique? The answer is no, because it can be either be 2, 3 and 4. and in any of the configuration my 2 3 4 will always come. So yeah, answer would be 0 for this particular index. Okay, so yeah, how you will solve this problem? So I'll tell you how you can implement. So first condition to check is that, like, if you are having a ranges like if you're having similar ranges, which means your smaller and larger ranges are equal. Okay, your smaller and larger ranges are equal, so you will store that particular indexes. Okay, done. Okay, but why? But there's only one case. If these two ranges are coming twice in the in your array, for example 1 comma 1 is coming once, and 1 comma 1 come 1 comma 1 is also coming another more time. So in this case, your 1 cannot be unique in any other case, because it will 1 over here, it will yield 1 over here, and it will also yield 1 over here. So yeah, you cannot avoid these two ones. You have to write 1 over here. So yeah, so the first condition is that if your smaller and larger range are equal and you're having two such occurrences, so both of them will cannot be unique, so you will simply write 1 in that cases. Okay, done. Now for this it will be 0, for this it will be 0, because they are both same, but you do not have any another index whose smaller and larger ranges are equal, which means you do not have 2 comma 2, right? So here it will be 0. Okay, done. Now another case. So another case, like 2 comma 3, and you occurring 2 comma 2, 2 comma 2 is also occurring, and 3 comma 3 is also occurring. So yeah, how to check these cases? Okay, first of all, store all of the indexes which are coming once. First of all, store index for that indexes whose small and larger range are equal. For example, this 2 and this 3. Okay, for example 4 comma 4 is also coming, right? So I'll store 4 also here. Now if there is a index, now while iterating on the indexes, if you check, like, both of the ranges are not equal. Okay, yeah, if my both of the ranges are not equal. Okay, done. Here you can see this range are not equal, which means the smaller and largest range are not equal. Okay, so if each and every index between smaller and larger range is coming as ones, and by ones I means as single points. For example, in this case, my each and every number between these two ranges will be 2 and 3, which means I can either choose 2 or I can either choose 3. So if my 2 comma 2 is coming or my 3 comma 3 is coming, then my answer will be no for this case, right? So this is the thing which I explained you in a above example also. But how to check? I'll simply check by using a binary search. Okay, first of all, store all of the numbers which are coming as which are coming in this form in an array and sort them. Okay, done. By sorting them, just use lower bound and upper bound on the particular range, this is 2 and 3. Okay, by making a lower bound of 2, I'll get at this index, and by getting a lower bound of 3, I'll get at this index. Okay, done. Now if difference between, first of all, check if you are getting these number only by getting the index of the lower bound. Okay, if I'm getting these numbers only because the lower bound of 2 is at this index and this value is equal to 2 only, and similarly for 3. So yeah, after finding and checking the conditions, find the difference between them. If the difference between them is also equal to the difference between the origin numbers, then your answer is no, because you cannot make them equal, because all of the numbers which are between 2 and 3 are coming are coming in the array also. Okay, which you make it, which you are made. And how will you make this array? By storing all of the numbers which will which will whose ranges are equal, right? So yeah, because if the ranges are equal, you will only able to write 2 only, so that's why I'm storing 2 over here, right? So yeah, if I show the code is also easy. Okay, yeah. So first of all, I will store the numbers whose ranges are equal. Okay, done. And insert them into a set, because I only want the unique indexes, and increase and store a frequency map also for the numbers whose ranges are equal. Okay, done. Then I'll store them in a array. The set, I'm converting the set into array. Okay, done. But why? To use binary search. I know you can also use the lower bound on set also, but yeah, for the easy implementation, I've converted this particular set in the array. Okay, done. Making answer array. Okay, done. Now I'm checking if my ranges are equal. Okay, if my ranges are equal, then I'm check whether these ranges are coming more than once. Okay, but why I'm checking? Because if 2 comma 2 and 2 comma 2 are coming twice, then answer will be no for both of them, right? So yeah, If the frequency of the ranges are greater than 1, then I'll store 0, else I'll store 1. Okay, done. Now else case. Else case is that in which my ranges are not equal. Okay, done. If my ranges are not equal, I'll check if each and every number which are coming in between these two ranges are coming in my array or not as a single index. Okay, and what is a single index? Whose ranges are not equal. Okay, whose ranges are equal. Done. So how I'll check this? I'll use lower bound and upper bound. I'll find index 1 and index 2. Okay, done. If my both of the index are in the array, okay, done. Because lower bound give you the last index of the array if the particular element is not found in the array. Okay, done. So I'll check if my both of the ranges, both the indexes are not equal to my last index. Okay, done. Now what I'll check, if my first index is equal to first value only and last value is equal to last value only, because if for example, if this is 3 comma 4 and suppose 5 over here, and I choose lower bound of 2 in this array, then it will give me 3, right? It will not give me 0, it will give me 3, because that's the behavior of lower bound. So that's why I'm checking over here if my index is only that index only which I was finding on, and similarly for the last value also. And last check is that this can be skipped also, but yeah, for the safer side I've used it. So if the difference between them is equal to difference between the ranges, then this is concluded that each and every number which is in between the ranges are coming in my array. Okay, done. If this is the case, then answer is 0, else answer is 1. And yeah, just print the answer and return it. You will get the solution code in the description. So yeah, let's now jump to problem number C, that is C. Okay, now, okay, done. How you will solve this particular problem? I'll explain you the problem over here. Okay. For example, you are given a range like this: 1, 2, 3, 4, 5, 6, and 7. Okay, done. And a k, and suppose a k of 1. I'll explain you the reason of k in the later part. But yeah, for now consider this only. Okay, this is a array which is given to you. And what you have to do, first of all, divide the array into two parts. Okay, if the length of array is odd, okay, if the length of array is odd, okay, then you cannot divide them in equal parts, right? So yeah, if that is the case, then just store the middle value in your answer. Okay, for example, this is score of your array, and if the length of your array is odd, then store the middle value in a score variable, and repeat the process on the smaller array. Okay, done. If this is my smaller array, in this case, my 1 2 3, my 2 is the middle part. Okay, done. Store the 2. Okay, done. And repeat the process for 1 and 3. Now this is only single 1, this is only single 3. Just store 1 and 3 in your answer. It will be plus 1, it will be plus 3. Okay, done. But yeah, and do repeat the process for the second part of the array also. This is 5 6 and 7. Store the 6 on store the 6 in your score, that is plus 6, and store the 5 over here and store the 7 over here, and add plus 7 and plus 5, right? So this will be your final score of the array. Okay, done. So yeah, but this is pretty straightforward. I'll explain you with another example. Okay, done. For example, 1 2 3 4 5 6 7 8 9 and 10. So in this case, your array has a size of even numbers. Okay, done. Now what to do in size of what to do in the array of size even numbers? Just break the array and repeat the process. But how? Like for example, in this case, there's no middle, right? So my score is 0 after the first breakout, right? Okay, now then I'll carry on this particular subarray or this particular part. So in this case, my middle part is 3. Okay, done. Okay, what is this array? 1 2 3 4 5. Yeah, so my in this case my middle array is 3, my middle element is 3. Okay, done. That is plus 3. I'll do plus 3 over here and repeat the process on this one 2 and this one 4 5. And similarly for this, my middle part is 8. This is 6 7 8 9 and 10. Okay, done. My middle part is 8, so I add 8 in my score and repeat the process on this 6 7 and 8 or 9. Okay, done. Now you can notice your 6 7 is of array, is of length even. So I'll again break it into 6 and into 7. Okay, and for this it is 9 and it is 10. And similarly here 1 2 4 and 5, and add them in your final score. Yeah, so this is the only case. But considering this, my uh, this is only case when my k is equal to 2. Yeah, k is equal to 1. So you are noticing one thing: if my k is equal to 1, then my answer is like sum of the whole array, right? So you might be thinking the problem must not be that easier, right? Yeah, so problem is not that easier. For example, if your k is k is 2, okay, done. If your k is 2, you will stop at the point where your array length is 2, okay, done. If where your array length is smaller than 2, okay, done. Here you can at this level, if I observe this particular level, you can see my all other arrays are of length 1 only, so I will not consider any of this element in my final answer. Okay, this is the only case in this is the only tricky part in this question. You have to stop where you have to stop at the place where your array length is becoming smaller than your given k. Okay, so yeah, so how to solve this particular problem? Once you can see that like I can use a recursive approach and stop where my length of particular segment is smaller than k, and I'll return the answer. So that is pretty much easy, but yeah, you cannot. So let me just write a brute force approach. For example, this is a particular function and accepting l and r and a k. Okay, done. Now in this function, like let's suppose if your r minus l plus 1 is smaller than k, then what I will do, I will just simply return, I will simply uh, return 0. Else I will repeat the case for uh, l comma mid minus 1 and plus. Similarly for the, okay, I'll show you the code only, this is difficult to write over here. So yeah, hope you got the point which I'm trying to say, like the recursive approach which you can use. Okay, done. Yeah, for example, let's suppose you ignore this particular part and this particular part. What you will do, you will just okay, let me explain you from the starting only. Okay, yeah, okay, let me write it over here. So yeah, I'm just modifying the original solution to explain you better, but the thing which you do not have to do, I'll write over here. uh, this is the odd case, so yeah, I'll write mid plus 1 comma r and comma k, right? Okay, now similarly for this is odd case, and yeah, and I'll write, yeah, this is same. Let's just ignore these two parts. So yeah, in the initial code, what you must be thinking of is like that: I'll call the function, make a function which will be accepting 1 comma n. Yeah, 1 comma n. Now it will be l comma r in my recursive approach, and if my distance between them, l minus r plus 1, is smaller than k, then I will return as a zero sum. And what I will do, I will check uh, if my, okay, I'll let some over here. Okay, done. So if my particular distance between them is odd, then I have to add mid also. Yeah, you must remember I have to add mid also, right? So in this case, what I will do, I'll add mid in my answer. Okay, done. I'll add mid in. You can ignore this part for this particular while. So yeah, I'll add mid in my answer and call the recursive approach for l mid minus 1 and mid plus 1 comma r. And similarly for the even case, I will not add mid over here and call the function for l comma mid and mid plus 1 comma r. Okay, yes, but you might be thinking this will give you a TLE in your final approach. Yeah, so I think so I can prove the complexity also, but why I'll not make it today only. So yeah, I'll tell you this will give you TLE by making two recursive call for each and every call. But you can also optimize this particular solution. But how? I'll tell you how. For example, let me take a case of 1, 2, 3, 4, 5, 6, 7. So what I want, I'll only make one call over here and find the answer for the my next call from the previous call only. So yeah, for example, this was my original code. Yeah. So if I tell you what is the, for example, I'll take example for k is equal to 1 only. Okay, I'll take example of k is equal to 1 only. So my mid is 4. Okay, then I'll find the answer for this. I'll find the answer for this. But yeah, now what I will do, I will try to find the answer using this array only for this array. Okay, well, for this part of the array from this part of the array. Okay, done. So yeah, for 1, 2, 3 over here and 4, 5, 6, 7 over here. Okay, done. Okay, is it recording right? Yeah, recording's on. Yeah, just fear. So for this particular part of array, what is my answer for the k is equal to 1? I'll divide it again. uh, my score is initially 4. Okay, done. What is the score for this part of the array? Okay, I divide it again because this is the middle part. This will give me 1, this will give me 3, 1 and 3. Okay, done. Now the score for right left part of the array would be 1 plus 2 plus 3. Okay, done. 1 plus 2 plus 3. Okay, done. Right. So how to find the answer for right part of the array using the left part of the array? So there's a pretty much pattern in this particular problem. I'll tell you what is that. So yeah, if you want to find, if you want the sum of the next part of the array, if you want the sum of the right part of the array from the left part of the array, what you have to do, just find the sum of the left part of the array. Okay, done. Now sum of the left part of the array is 6. Okay, done. 6 multiply it with 2. Okay, done. Multiply it with 2, adding it, what you will add in this particular problem, you will notice mid. What is mid? Here you can see my mid is 4. Okay, mid multiplied by size of my left array. What is the size of my left array? That is 3. Okay, done. Okay, uh, or I can see the number of segments in which I have divided it into. So that what are the number of segments? 1, 2 and 3. Okay, done. But how I'm calculating this? So this will be, let me repeat it again. You are having left part of the array. Okay, you are having a sum as a 6 of the left part of the array. Now you want to find the total sum of the right part of the array using the left part of the array only. How to find it? Just take the sum of the left part of the array, multiply it with 2, plus add it with the mid part, that is 4, and multiply it with the number of segments which you have computed in the left part of the array, because that is the number of segments which you will be computing in the right part of the array also. Yeah. So yeah, what you will get, it will be 12 plus 12, that is 24. Now tell me, is the sum of the right and the left part of the array 24 or not? So in the left part of the array, what is the total sum? That is a 5, 6 and 7, because these three will be adding, because my k is equal to 1. So yeah, the sum of 1 plus 2 plus 3 plus 5 plus 6 plus 7, that is 24. And what you will return, 24 plus 4, that is 28. Okay, done. But this is the case when k is equal to 1. How to prove it when k is equal to when k is greater than 1? I'll tell you that also. For example, 1, 2, 3, 4, 5, 6 and 7. And in this case my k is equal to 2. Okay, done. What I will do, I'll repeat the process. Is I'm taking 4. Okay, done. This is my mid. Okay, done. I'll take this particular subarray, that is 1, 2 and 3. Now I'll take this particular subarray, that is 5, 6 and 7. Okay, done. Now 4k is equal to 2. Now I will add 2 over here. Okay, done. Because this is the mid part, and I will not compute 1 and 3 because the size of the array is smaller than 2, which I will not compute. And in this case it will be 6, and I will not compute 5 and 7. So let me make it with the blue line, because I will not compute because the size is smaller than 2. Okay, done. Now how to get the answer for 3? Now how to get the answer for this particular index 2? So score will be 2. So what was my formula? That is 2 multiplied by 2. Okay, done. Adding it with my particular index 4. And okay, 4, yeah, just a second. The number of segments are 2, I guess. That will be 6, 12, 4, 8. Yeah, so yeah, the number of segments in this case would be my 2, because I'm computing it at the, okay, yeah. So yeah, this will be 2, and for this particular index it will be, I think so, I am missing something, must be a point, just a second. uh, that will be 2, but I have written over here the formula. That is the size, and the multiplication would be 12 and 4. mm, why it is coming to, I think so. I have make a condition over here, but I'll explain it with a this index only then. Yeah. So hope so you got this particular index. I'll come back to this particular index in the later part. I'll tell you the reason in the comments. So yeah, hope so you got the point. The if you have the value for the left part of the array, you can easily compute the right part of the array by using the number of segments, or I can use the length also. So yeah, but how? That is value of the left part of the array, that is 6, multiplied by 2, adding it the middle part multiplied by the like multiplication of it by the segment size. And what is the segment size? In this case it will be 3. So yeah, mm, I think so. Maybe no, maybe yes. Yeah. So like let me explain the code over here. So yeah, I'll take the middle part. That is the sum which I will be adding. Okay, done. If my length of the array is odd, what I will do, I'll just find the right part of the array, the left part of the array, that will be L comma mid minus 1. Okay, okay, then now now you can notice it is pair in combine. Here my first value will be containing the sum, and the second the segment size from whom I will be multiplying it with. Okay, done. In the next part, if it is odd, you know one thing, I have to add the sum also. Yeah, I have to add sum also. Now if I ignore the sum, now to get the total sum would be the value of the left part, that is value comma first multiplied with 2, adding the mid into segment size. The segment size will be the second value of my particular recursive function. And how I'm computing the second size? This is, in this case, the segment number would be 2 into num dot size plus 1, because it is odd. Yeah, it is odd, right? So for example, if this part is odd, then the segment size of the whole array would be segment size of this into 2 plus 1, because this is odd. I'll add 1 for this mid value. Okay, done. 2 into segment size plus 1, and return the sum. Similarly, for the even case, I will not add this particular mid, and find the sum as 2 into left sum plus adding it with the middle into segment size of my left part. Okay, done. And here I'll return 2 into just simply segment size, because if my size of the array is odd, there's no middle part, so I'll ignore the plus 1 in the even part and return it. Okay, so yeah, or what is your final answer? That will be the first of your recursive code. That is the first value which is written by your recursive code now. So I'll get back to this particular example in the comment section. So yeah, I think there's some confusion in that. So I'll now explain the D part, D quotient. So that is redefine products optimality. So yeah, okay, done. So you are given two arrays. Okay, done. You are given two arrays. The you are given two arrays. Okay, done. Now what is the P? P is defined as the product of the minimum value for each and every index of A and B. Okay, done. Let me explain you here only. For example, you are given array as 1, 2, 3, 6, 5, and let's suppose 2 over here, and here it will be 8, 3, 2, 1, and 2 over here. So the minimum of the first index is 1, the minimum of this is 2, here it is 2, here it is 1, and here is 2. So multiplication of all this, so the multiplication of all of this, the multiplication of all of these elements, it will be my P. Okay, done. I'll get the P over here. But there's a condition in this case, in this question. You can rearrange the elements of A and B before before continuing with the operation. Okay, done. What is the operation? You will be given two operations. One is like, you can operation in the form of 1 comma index. Okay, done. If your first value is 1, then just increase the index of the first array by 1. If the first value is 2, then increase the index of the second array by 1. So these are the queries which will be given to you. And there is also case you can rearrange the elements of A and B before proceeding with the queries. Okay, done. So the question lies with it. So rearrange the elements of A and B before going on the queries. And yeah, after each and every query, just find the p, just find this value, which means, for example, I'm having a this index as 2. Okay, done. Just increase the value of 2. For example, before each and every query, my answer is here the multiplication is 2 2 4 and yeah 8. Okay, done. If I increase my second index of the first array by 1, that is 3, I'll increase it by 4. Okay, done. Now you notice one thing, that the minimum does not changes. Minimum is 2 again. So yeah, after this query, my answer would be 8 only. Okay, done. For example, in this case, for in this query, my second query gives me index of 3. Okay, I'll increase my this one by 2. Now this changes my minimum also. So yeah, now the minimum changes to 1 2 2. Now here the minimum will be 2 only. This is 2, and in this case my answer would be 16. So yeah, after this query my answer changes to 16, and before this query my answer was 8, and yeah, that is the thing which you have to output. Okay, done. So by like observing a pattern, you must notice one thing, that the rearranging the elements, rearranging the elements only means sorting the both of the arrays. That is the only thing. Okay, so sort both of the array. This is the only reordering which you will be doing in this whole question. Okay, done. Rearrange the elements of the array. Okay, done. That is 3 again. Okay, this will do 5 and okay 3 and 5. Okay, done. I'll arrange the particular array second also, that is 1 2 2 3 and 8. Okay, done. Now apply the queries and find the answer, but that is not this much simple. So yeah, I'll tell you how. So if the query is of first index, okay, I'll tell you with respect to only one array only. Okay, I'll just, can I copy it? Maybe yes. Okay, I guess I can copy it. Yeah, hope so it is copied correctly. Yeah, so what I will do, for example, I'm given a query of 0 comma 1 comma 2. Let me make a case, 1 comma 2. Okay, done. So first of all you have to find the initial answer also. For the initial answer, just sort the both of the array and find the minimum for each and every index and multiply it with, yeah. So find the answer for this particular array. For example, in this case the answer would be 1, here minimum is 2, here is again 2, here is again 3, and here is 5. Yeah, so the answer in this case, the multiplication of all these numbers is like currently 4, uh, 12 and 60. So yeah, okay, done. 60 is my current score. I'll print 60 because first answer I have to print with respect to 0 operations. Okay, done. Now my first query is of 1 comma 2. Okay, done. My first query is 1 comma 2, which means I have to increase the 2th index of my I have to increase the second index of my first array. Okay, done. I'll increase it by 3. Okay, done. Now what I'll do, I know I am on second index. So what, I am on second index. What was the minimum of the second index? The minimum of the second index was 2. Okay, done. Before making the query, I'll divide it by 2 because this is not anymore I'll modify the contribution because you know that before the answer, before the modification, my query is my this particular index give me minimum as 2, right? So after the query, this can be modified, right? This can be modified. So I'll divide it by final score, which I have got previously, and multiplied with the new score. Okay, done. So this is the thing which you have to repeat in each and every case. Okay, done. But how? This is simple. Just find the score initially, and for each and every index on which you are currently operating, just first of all simply divide the previous minimum value, okay, from the score, and multiply the new minimum value. Okay, in this case it is not getting changed. So yeah, in the next query I'll get of 2 comma 3. Okay, done. Which means I have to increase the third index of my second array. I'll increase it by 4. Okay, I think so I can take uh, fourth index of my fourth index of my first array. Okay, I'll take this fourth index of first array. Okay, I'll increase this 5 to 6. Okay, done. Now there's a case over here. So what is my current score? Current score is 60 because after this operation I'll get 60 only. So yeah, I'll divide 5 from the 60 because that was my previous minimum. Just divide the 5 from the 60 and multiply it with the new minimum. The new minimum of 5 comma 6 comma 8 is 6 only. So I'll update 6 over here and multiply it with 6. Now you will get another value, and yeah, just append this in your array and you'll get the answer. Yeah, but there is some edge cases which you have to take care of. So I'll tell you the edge cases. If you are having duplicates, okay, here you can see I have two twos. Okay, I have two twos in my array. Just always focus on the last index. Always focus on the last index, because after increasing, for example, I'm increasing this two. Okay, then after increasing you have to modify the last index of your two also. Okay, for example, in this case my last index of 2 was 1 2 3. Okay, done. But if my this particular 2 is increased by 1, then my last index of 2 will be decreased by 1 index. Okay, done. I'll decrease it. Now you will also notice one thing, that my new occurrence of 3 is coming, because I now I will convert this 2 into 3. Okay, done. If my 3 is previously occurring in my array, then I have not to change the index of my 3, because that will be updated to the latest index only. But if this is not 3, this is 4 over here, this is 4 over here. Now you will notice one thing, that 3 is new in this array, so I have to update the last index of 3 as 3. Okay, so this is the condition which you have to just take care in the mind. And yeah, and you know one thing, you have to take care of the modulus also, because by dividing it you have to do it in the terms of modulus inverse. So I hope so you know the concept of modulus inverse before solving the question. So yeah, I'll explain the code part. So yeah, just take the input of the both of the array, sort both of them, and yeah, just store the last index of each and every index, because that is the thing which you will be concerning of, right? Just store the last index and increase and make a frequency count for the array also. Okay, done. Find the initial answer. Initial answer will be minimum of each and every index, and the make the modulus, because that is a necessary part. Insert the first answer in your first result in your answer array. Okay, done. Now for the each and every query, if type is 1, if type is 1, okay, done. Now you can these are the both the same code, but just occurring for the a and b array. I'll explain the first for the first array only. If my type is 1, just find the index on which number you will be operating, and find the index of that index, or find the index of that particular number whom you will be operating. Okay, done. Just decrease the frequency of your initial number, because initial number will be increased to 1, increased by 1, so the frequency will also be decreased, right? So yeah, if the frequency is getting 0, you can just assign the last index to 0, or any other random value, or I'll take -1 over here, because that is no more occurring in my array. I'll make it -1. Else what I will do, if the frequency is not 0, I'll just decrease the frequency, I'll just decrease the last index. But what is this case? In this you can see 2 is coming twice, which means after reducing the frequency of 2 by 1, there is one more occurrence of 2, there is one more occurrence of 2 2. So I'll just decrease the frequency of 2 by 1, because earlier it was on this index, now it is no more 2, it is now 3. So the occurrence of 3, now the occurrence of 2 will be decreased by 1. So yeah, that is the thing which I'm doing over here. Now you have to just divide the result by the previous minimum value. So I'm using a modulus inverse case in this case. So yeah, just divide the result by previous minimum. Yeah, this don't misunderstood it with multiplication. This is modulus inverse. I'm dividing the previous minimum by the result. Okay, done. Now another case, I have to increase the frequency. I have to now next number, I have to multiply it with next number also. Yes. So yeah, just increase your number. Okay, done. Increase its frequency also. If its frequency is 1, which means it is first time occurring in the array, which means here you can see this is 3. Now 3 is occurring first time in your first array. Now first time in your first array. So if it is the first time, then you have to update the index also, right? Just update the index with your current I. Yeah, and multiply the result with the new minimum of both of them, that is 2 again. So yeah, and make it the modulus and store in the array. So this is the only this is the explanation of problem body. If you have any doubts in any of these 4 problems, please comment me down, and till then stay tuned for the next one. Thank you. And just a reminder, I'll get back this to I guess where was it? Yeah, I'll get back this particular index in the comments. Yeah, so that's all. Thanks for watching. Bye.